Okay, so I'm going to do identifying even and odd functions. So before it was just kind of a general equations, and then we were looking at symmetry. Here I'm going to do even and odd functions. I want to recognize when it's an even, when it's an odd function, and then state some facts about what the symmetry would look like if I identify it as an even or odd function. So we're going to do the same thing, but I'm going to use functional notation, do some of the very same things I did with the symmetry part, and we'll go from there. Okay. So identifying even and odd functions. I'm going to do a symmetric test with respect to the y-axis, and then I'm going to use this functional notation. Okay, so I'm going to say if I take a negative x, I'm starting with f of x. Everywhere I see this x in my rule, I replace it with negative x. And if these two output values, the y's, are the same, then it's symmetric with respect to the y-axis. So the ones that we have looked at already, let's kind of do this with a real simple one. So if I start out with f of x is x squared, and I put a negative x in there, that means wherever I saw the x, I do a parentheses instead, replace it with a parentheses, and then I square. So this is the same thing now as negative 1 squared x squared. Like that. And negative 1 squared is 1, so this is just, I'm dropping the parentheses because it's standalone, and that was x squared. That's saying that here's negative x. Well, this looks just like that part. If this is equal to this is equal to this, and this is equal to each other. Okay? If A is equal to B, B is equal to C, what can we say about A and C? A is equal to C. That's kind of what this is. This is equal to B, right? The B is equal to this, then these two must be equal. This, when f of negative x turns out to be the very same thing as f with a positive, this is called an even function. Okay, that's called an even function, and even functions are symmetric with respect to the y-axis. All I have to do is graph out one half of it. The other half is going to be the very same thing, except it's a negative x down this way. The y's are the same. Okay. If this turns out to be true, odd function, so if I take a negative x and it turns out to be the negative of the first function, then it's called an odd function, and that's symmetric with respect to the origin. Okay, so let's do it with f of x is equal to x cubed. Okay, we know what that graph looks like, right? This is this guy. I already know, I have a picture in my mind, that's what that is. They're the very same. Okay, with respect to the origin, says remember, if I've got an xy, then on the other side, whatever that value is for negative x, so this is 2, 4, this would be negative 2, negative 4. Okay, that's with respect to the origin. Okay, so this is what I have to do. I have to see if f of negative x is the negative of f of x. Okay, so I'll replace my f of x, so I say, what is that? Okay, everywhere I see the x, I want to replace it by parentheses. If I've got other stuff, all the x's, and then I fill it in with whatever goes there. It says evaluate the function at negative x. And this turns out to be the negative 1 cubed x cubed. I got a times a b, negative 1 times x. So now this is negative 1 times x cubed, which is just negative x cubed. And this is the same thing as if I said negative my f of x, which is negative my x cubed, which is the same thing as negative x cubed. Okay? So anytime f of x, f of negative x, is negative f of x, this is an odd function, and it's symmetrical with respect to the origin. And again, we will not use this notation if it's symmetric with respect to the x-axis because it's not even a function. Okay, so we don't have to worry about any of these. Okay, this is the odd function. Okay. Odd function being not being strange, a strange function. It is the odd value. Okay, and the odd, you should think of this as evens are going to be the even powers 2, 4, 6, 8. Odds are going to be 3, 5, 7, 9, those odd numbers as powers. Okay, so let's kind of look. It doesn't have to be either one of these things. This is kind of a strange one, so I wouldn't, let me do another one, because this is like x squared minus x squared plus 2. I don't know where they come up with that stuff. Notice that that's from the publisher. But let's go x to the 4th minus x squared plus 2. This makes more sense. Okay, so I've got two different powers. I can't combine them. Okay, so now any place, so I'm going to check for even. Is this an even function? So all I'm going to do is do this. I'm going to evaluate f of negative x. Write my parentheses first, and then I write what I need to put in there. This is plus 2. Even, so this is going to be negative 1 to the 4th. This is the same thing as x to the 4th. Evens minus x squared plus 2. Okay, so this is an even function. This would be symmetric. So wherever how this thing graphs, the very same thing on the other side. So let's, plus 2, I would say. I would say it's going to look something like this, plus 2. But let's look. There's some negative. I don't want to do that. Hold on. Where's my Desmos? Where's my Desmos? I want to graph this thing. And then note its symmetry. X to the 4th minus x squared plus 2. That's what that would look like. Symmetric with respect to the y-axis. X-axis we don't have to worry about. The origin clearly not. Okay. If I stuck the negative x, so if this would have been all negatives where this had flipped, that would be an odd function. I can't be even and odd at the same time. Okay, I'm either even or an odd function. So I can't be symmetric with respect to the x-axis because that's not even a function. Okay, I'm either the y-axis or here the origin plus and the minus down here, and if it's with respect to the origin, then it's not symmetric with respect to the y-axis. I can't just fold it over. Okay. So here the even, I get symmetry with respect to the y-axis. So it turned out something like that. Okay, but a mirror image. This is a little better picture. I should do like that. How about this one? x cubed minus x plus 3. I'll replace it with negative x and this is what I get. I get negative x cubed, but here I get a positive x plus 3. Okay, so this is not the same thing that I started with. So it's not even. It's not symmetric with respect to the y-axis. Is this, so here is this, that's the this. Is that equal to negative f of x? So if I started, and if I multiplied negative x here and compare them, do I get that? So negative f of x would be negative x cubed plus x minus 3. This was plus. And here, this one's okay, but this is not. So these two are not equal. F of negative x does not equal negative of the original function. The negative of the original function is this guy. So neither. Neither means no symmetry. Okay. So now here's the very same thing, okay? But I do not have the 3. So I've got f of x is equal to x cubed minus x, okay? So I want to check for even function. And it's not going to be even. Only the things that's going to work this out is if all of these were even power, so all of the negative x's would be turned to pluses, okay? Even if f of negative x is equal to the very same thing. Okay, so if I put an f of negative x in here, again, cubed like this, I get negative x cubed because this is negative 1 cubed x cubed, and then this is plus x, okay? So not even, right? It's not even because this does not equal to f of x. This. Negative x cubed plus x is not the same thing as x cubed minus x. But if I multiply a negative 1, so now I'm going to check for odd. And in that case, when I did this, I got a negative of what we started with. Okay? This is negative the x cubed minus x. Distribute, minus x cubed plus x. And that's what we ended up here. So this is an odd function. Okay. In terms of symmetry, if it was even, it would be with respect to the y-axis. The odd functions are with respect, it wasn't even, but this was with respect to the origin. So whenever I have something up here on a graph, this graph is going to look something like this, so that anytime I had a number 2, 7, if I graph this out, I put points in here and did this, then I would be given that negative 2, negative 7 would be down here, okay? The exact opposite from origin. Okay, so here, all the powers were odd. Constants were not in here, okay? Evens I can shift up and down, there still be symmetric, but I can't shift an odd function up. In other words, from our transformations, if I start with the basic graph, let's do y is equal to x third, but this is in any of them, so this could be the fifth, right? It would look like the same, but this would be tightened up a little bit. Okay, I can't take a transformation, vertical transformation, f of x plus 5, vertical just shifting up 5. This would be, now this would be my 0 point, would go up to 5. So this would look something like this. This is no longer symmetric with respect to this. Okay, so 1, so if y is equal to x to the 5th plus 5. If I've got 1, f of 1 would be 1 to the 5th, 1 plus 5 is 6. But now if I do negative 1, it would not be negative 6. Okay, this would be negative 1 to the 5th plus 5. This was 1. This is negative 1. This is now 4. Okay, so this is 1, 6. Negative 1, 4. I've lost this would be negative 1, so negative 1. This would be, I'm sorry, plus 1 would be plus 1. Negative 1 to the 5th is negative 1. That's that symmetry. By shifting an odd, I started out with an odd function. This is odd, but now I've lost that odd function, not odd. In terms of what we're doing with symmetry, even odd function. I can do it with an even function, that same transformation. So if I've got y is equal to x squared or x to the 4th, let's just do something away from that. It's the very same thing. I've got this just a sharper, okay? Anytime I put like a, just do 1, 1, 1, negative 1 to the 4th is plus 1, okay? But I can shift this up, so this is even, okay? Symmetry with respect to y-axis, okay, I can fold this over. But here I can also do it if I do the transformation y is equal to f of x plus 5, which just looks like x to the 4th plus 5. Take my original, move it up to 5, so now that's at 0, 5. I still have symmetry with respect to the y-axis. So if I have f of 2, now let me do 1. 1 to the 4th is 1 plus 5 is 6. F to the negative 1, negative 1 to the 4th is still 1 plus 5. That's still 6. So I've got 1, 6, negative 1, 6. They're going to be the same y value. That's the even and symmetry with respect to the y-axis. Okay, determine if the function is even, odd, or neither from the graph. Okay. So the properties of an even function. If even, symmetry with respect to WRT, the y-axis, both ways. If I look over here, if I took from here out and folded it over, I get exactly the same thing. So this is an even function. I can't be even and odd at the same thing. This would be flipped over. So if that wasn't turned out to be an odd function, it would look like, let me see if I can kind of do this out here. This would be the same thing as here, here, and here. Okay. It would be actually have to kind of a fold and then a flip. Okay. That's what if it was odd. Okay. And neither would be neither of those things. Okay. So that one is symmetric with respect to the y-axis. So it's an even function. Even. Even, odd, or neither. Okay. So this one, again, if I looked at the origin, it looks like as I'm going up, I'm going down. If I'm going down, I'm starting to go back up. Going down, going up, that mirror image across this way, and then this one's going up, that one's going down, and there. Okay, so this is an odd function. It's symmetric with respect to the origin. It's symmetric with respect to the origin from the graph, therefore it's an odd function. Okay. This one is symmetric with respect to the y-axis, so therefore it's an even function. So it goes both ways. Okay. If I get symmetry with respect to the y, I get even. If it's even, I get symmetry with respect to the y. If it's symmetric with respect to the origin, so it's a mirror image across the origin, that graph is, so it's called an odd function. That's based from an odd function. Okay. Okay, determine if the function is even, odd, or neither. Amy, does that look like an even, odd, or neither?
Even.
So that would be an even function. If I folded this back across there, if I folded it, if I did like a little fold, you see me on my hands? If I fold this across that y-axis, I get the very same thing. So that's an even function. It's symmetric with respect to the y-axis. Okay, so this one, this has got pieces here, 3 different pieces. Again, we'll look at something like this later on. This is a rational function with some vertical asymptotes here, and then the horizontal asymptote going to 0. We'll see all of that later on. I think that's going to be, that may not be that piece of it, but either way, this, if I'm positive here, I go to negative, and then negative here is positive here. This would be an odd function. This is symmetric with respect to the origin. That's what a graph looks like that is symmetric with respect to the origin. So therefore, it's an odd function. Here, I get neither for C. If I fold this back over, I get something that looks like that. So I go from I'm going from here, and if I folded, I would get that, and these two are not the same thing. So not symmetric with respect to y-axis. Okay. And I would have a hard time trying to draw this as a reflection around the origin, but it would be kind of that stuff if I did that. This, when I go across here, I should immediately be, so if this is a positive x, positive y, I should have something negative x, negative y. So it's not with respect to the origin. That's what I'm looking for. I should be able to fold this down around here. So take this and kind of fold it, you know, over, and then a flip is the best thing I can say. If I went, this is the over, I would need a flip to get that to work out, and then that's still not going to work out. Okay, let's look at some more. Okay, even, odd, or neither from the functional rule. These are functional rules. The other one, here's a function, here's a graph. There's also here some sets. We could look at the set, some numbers, and which would be even, which would be odd. For instance, if I had a set, here's my relationship, and I'm going to call them a function because I have this. I have -2 going to 4, -1 going to 2. Then I have 2 going to 4, 1 going to 2. Okay. This is f of -x being the same thing as f of x. Okay. The very same, for the negative versions, I've got the same y. Remember, an ordered pair looks like that in terms of function land. This is the x value, the outside is the y value. Okay, so that would be even. Okay, anytime I have something like that. Okay. So let's go through though and do from the rule. Okay, and I'm going to tell you right, if I look at this and do my preliminary analysis, all odd powers and no constant, that's going to be an odd function. Symmetry with respect to origin. Just by looking at this and seeing that there's no constant but all odd powers. Okay. Now if I do the formal analysis, I'm going to say even f of -x, does that equal to the same thing? That's the even. Okay. So I'm going to go m of -x. I'm not going to rewrite this. I'm just going to put this in here. Equals to negative. Where this x is, I put parentheses and now I put a -x in here. Raise it to the same power, plus parentheses. That's what evaluating this there looks like. This is an odd. So -1 times -1. Now this is x to the 5th. This -1 is now minus x cubed. Okay. So no, it's not even. However, is it odd? Does f of m of -x, is that the same thing as negative m of x? If I multiply this by -1, I can also do this. I can factor out a -1 and say, okay, if I do all the -1s, this is the same thing as what I start with. But I like the easiest way is just multiply this by -1. And this side would be negative times negative, that would be the x cubed, plus x would now be a minus x. This would be the m of -x. Is that the same? Yes, so it's an odd function. Symmetry with respect to origin. Okay. So n of x is equal to x squared minus the absolute value of x plus 1. Symmetry, that's an even. That's even from our basic knowledge. And then this is just shifting up. So I can do a y symmetry with respect to the y and shift it up. Okay, we'll graph this out in just a minute, but I want to do the formal analysis. So I start always with this. Is that the very same thing? If it is, then it's even and I get symmetry with respect to the y. So n of minus x, what does that look like? Parentheses squared, negative x goes in there, minus the absolute value of x. That goes in there, plus 1. And then I simplify. What do I know? This is minus 1 squared. X squared minus 1 squared is plus. This is just x squared. The absolute value of x and negative x is the very same thing. No matter what number I put in here, it's going to be the same number except the sign flipped, and that's always going to be the positive number. So this is the very same thing as that. This is the very same thing as that. The answer is yes. So even. It's not going to be even and odd at the same time. If it's even, it's not going to be odd, and it's not going to be neither. So stop. Okay. This is even. So graph has symmetry with respect to the y-axis. Okay. And the way I said yes to start with, I knew this was a symmetric with respect to the y, that's an even function. Here we looked earlier, I knew this one's going to be with respect, this is almost like, just moving up and down or subtracting the two, and this is just shifting everything, and around the y-axis that should be the same. Okay, so if I look at this, if I can get this graphed out, I'm going to say y, I'm going to use my y value, is equal to x squared minus, and I'm just going to use the bars for this, x, and then plus 1. And if I come back over here, that's what that's going to look like. And if I take this and fold it across, anytime I'm at here, so here is 1, no, this is 0.5, and the y value is 0.75, this would be negative 0.5, the very same y. And that's the way symmetry, so if I saw this graph, we'd say, okay, if I fold this back over, yeah, that would be a symmetric with respect to the y-axis, that would be an even. We know what this is, we've done the analysis, we know it's even from the analysis. So we knew that the graph would be symmetric. Both ways would work. Okay, so let me grab right there. Hold on. Let me do one thing. Record button so I can get this for later. So P of x, 2 times the absolute value of x plus x. Okay, so let's do some preliminary analysis. Okay, this is what, at my point of the game, this is what I'm thinking. I know what that looks like. That is that V-shaped function. That's even, that's symmetric with respect to the y-axis. The 2 is just a transformation. It's just going to tighten that thing up in, right? Do a scaling. But what about if I add another function? That thing is just a straight line. I can't add this with down here and have anything but an even and an odd, and that looks like it's going to be a neither situation. Okay, I wouldn't expect anything. I would have to plot points or go to Desmos to even look at what that graph would look like. Okay, because I'd have something here, 2 times a positive version of it, plus a version, I've got some weird stuff going on, and I don't think it would be symmetry-wise because of negative x here. But let's go through now the formal analysis. That's just kind of my intuition of saying this is neither because I've got an even. 1 is an odd number. That's certainly not respect. By itself, I've got some origin. So this by itself would be symmetric with respect to the origin. This one is like that. But this one, remember, is like that. And if I add this and this, I kind of lose my symmetry. This would be a negative numbers over here, and then I'm subtracting. So my guess, from just, my experience, I'd say neither, but let's go through the formal methods, okay? And my formal, I'm going to go through even, check for, do this. If this is it, I'm good, because I can't be even odd at the same time. I can't be even in neither. So I start with this one. does P of x, P of negative x, is that the very same thing as P of x? So for negative numbers in here, P of negative x, what does that look like? 2 that plus, here I'm doing parentheses, kind of a parentheses in here, but that's okay because that absolute value takes care of that. But I may need to put it in here as well. This now comes out, right? Plus times a minus is a minus. But again, absolute value of negative x is equal to the absolute value of x. So this is 2 absolute value of x because of that, but this is now minus x. This, if I look piece by piece, that's the same. This is not the same, so it's not even. Is it odd? Well, to be odd, this would have to be what the negative of that would be. So if I multiply this, negative 1 times, I'm going to put a brace, 2 absolute value of x plus x. Let me kind of slide this over so catch the other half of this. So the negative 2 absolute value of x plus x, that is equal to distribute minus 2 absolute value of x minus x. And that is not the same thing as what we got there. So this is not the same thing as that 2 absolute value of x minus x. So that's not this that we got from before, okay? So that tells us it's not odd. If it's not even, not odd, then it has to be neither. That's your choice. Okay, even, odd, neither. Where is this here? Okay. So I want to spend a minute looking at piecewise. We're going to come back to this. We'll work some more of these things later. We'll do that in the lab. But piecewise defined functions, I want to kind of go over this. And it's kind of a mixture of what we've seen from graphing. We know kind of what this looks. We've done these things, and we were doing these things as far as domain and range. But now we want to look at these things in terms of how to build a function that we don't have a smooth function that matches, and we have to do these things called piecewise functions. Okay. And then how to read them. So I don't have the graph. I can't go over here and look at them. How do I use this information, this definition of a piecewise? This is what a piecewise defined function is. And then how to evaluate those in there. Okay, what is this thing telling us to start with? So I've got this. This is a piecewise defined function. And all piecewise defined functions look something like this. I've got some big curly brace. Here is this thing for some domain, like x less. It could be different things. Now this is a big, but something else. So I'm going to say, for ours, x squared plus 1, x minus 1 for other pieces of it. And this could be all the way down. So I could have a different function for some other range or some other piece of the domain. These are pieces of the domain, okay? Okay, so the full domain of f of x is, for this one, x less than 0 and then x greater than or equal to 0. That's what that looks like. It's defined for everything, but for a piece of it, I've got to go, whenever I'm evaluating, I have to find out which piece the number is. Okay. So again, I'll break down the domain. This gives me everything. This is kind of the big domain of the function. And then kind of sub-pieces of the domain I have to look over here. Okay. So for my first question is, given that, what is the value of f of -1? So it may not always be the graph, but what does the graph look like? I would go over and read this thing over. I'd go over -1 on the graph and then up, and it looks pretty close to being 2. -1, 2, right in there. So I'm thinking this thing should be approximately equal to 2 from graph. I may not be able to read it. That's what it looks like. It looks like it goes through. Okay, so that's what I'm looking for, but how do I do it? So I go here and I look at this piece and that piece to find out which one I'm going to use. So I start from the top, left to right, find my first match. Is -1 less than 0? That's my x value, my -1. Is that less than 0? Yes. So this is the piece that I use. So f of x, f of -1, is I go up here, I use this version of it. -1 squared plus 1, and that is 1 plus 1, that's 2. So that would be the first one. Okay. What is f of 0? Okay. Again, I find my piece over here and I say, is 0 less than 0? No. 0 is not less than 0, it's equal to 0. I go to the next one. This was my x greater than or equal to. So is 0 greater than or equal to 0? Yes, it is equal to. This is greater than or equal to. Okay, I can't be both at the same time here, but I can be equal to it. Yes, so this is the piece that I'd use. I go f of 0 now is, there's my x minus 1. My x value is 0, and this is -1. So this is -1. F of 0 is -1. If I go over here, f of 0, I don't use the open hole. I use the closed one, and that's the -1. That's what I was expecting. And then f of 5, again, I go through here and I say, is 5 less than 0? No. Is 5 greater than or equal to 0? And this could be split like a half a dozen, as many pieces as I need to get this odd shaped graph going. And then I would just match up as I keep going down which one makes it. This one does, because this is just split into 2. So I use that version again. 5 minus 1 is equal to 4. The graph is -1, 2, 0, -1, 5, 4. -1, 2 over on the graph, 0, -1, that's that point. And then f of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, that's my 5, 4 piece. Okay, and this continues on this way, this continues on that way. There's no end points. And that's why I said, so the full domain is negative infinity to infinity. Okay, so let me stop it at this point.